Hi everyone. Today I have choose a topic to present a paper like generating sequence with recurrent neural networks presented by Mukkisa Vijendhar Reddy. Coming to abstract, the paper demonstrates how long short-term memory recurrent neural networks can generate complex sequences with long-range structure by predicting one data point at a time. Application include text and online handwriting, extended to handwriting synthesis by conditioning predictions on text sequences. Now we are introducing to RNNs. Recurrent neural networks are dynamic models used to generate sequence in domains such as music, text, and motion capture data. RNNs predict future data points by processing real data sequences on one step at a time. Here is a diagram for RNN, like it has output, hidden layers, and the inputs. RNNs in sequence generation. It can be novel sequences by sampling from their output distribution and feeding the sample back as input. This process includes a distribution over sequence condition and a previous input. RNNs use high dimensional interpolation between training examples like unlike n-gram models, challenging the stranded RNAs. Our standard RNN struggle to store information about past inputs for long period, leading to instability in sequence generation. The anemia problem reduces their problem ability to make model long-range structure. Injecting noise into predictions or improving memory can mitigate these issues. Introduction to LSTM. Long short-term memory architecture is designed to better store and access information. It has slow it has shown state-of-the-art results in tasks like speech and handwritten recognition. LSTM can generate complex, realistic sequences with long-range structure. Here is the diagram for like LSTM cell, and it has input gate, output gate, cell, and forget gate, and the other stuff are been included here. And the points on LSTM is like architecture, which uses purpose built memory cells to store information, but for better finding it and exploring the long range dependencies in the data. And the before figure illustrates a single LSTM cell memory for the variation version of LSTM used in the paper. H is implemented by the following composite function, and below is the equation for getting that cell, and the further details are added in the next paragraph. And moving to the next slide, comes to the deep RNN architecture. This paper, like in this paper, the deep has defined as RNN composed of stacked LSTM layers. Input sequences are passed thoroughly multiple recurrent connected hidden layers to compute output sequences. The network is deep in the both space and time, with skip connections to mitigate the vanishing gradient problems. The training of deep RNNs. The network is trained for next step prediction and sequence generation. The probability given by the network to the input sequence is calculated, and the sequence loss is the negative logarithm of this probability. Back propagation through time and gradient descent are used for training. The prediction with RNNs. The prediction network was applied to text datasets like Penn Treebank and Huster Price Wikipedia datasets. The network achieved competitive performance with state-of-the-art language models. It effectively modeled long-range dependencies with examples of generated Wikipedia text. And the results for the text prediction, which has been given for before testing. Results are like results on the pin tree bank datasets showed that character level networks performed well. Like it means like when both the character level networks are very good in performing in tree bank datasets. With improved performance, with regularization was used. The network demonstrated rapid adaptation to new data. Results on the Wikipedia dataset showed better performance with dynamic evaluation. And next, coming to handwriting prediction. This is more important in this paper, which focused in the paper a lot. The network was applied to online handwriting data from the IAM online handwriting database. The network learned by generate strokes, letters, and short words directly from pen traces. Pen traces. It modeled global features of handwriting style, demonstrating flexibility and memory. And next comes like mixture of density outputs. The mixture of density outputs use the output of neural network to parameterize a mixture distribution applied to handwriting data, and a mixture of bivariant gauzes by uses to predict pen offsets. This approach allows the network to handle real valued input effectively. Handwriting synthesis. Handwriting synthesis involves generating handwriting for a given text. The soft window approach dynamically aligns the text with pen locations, guiding the network's prediction. And this method allows the network to generate convincing handwriting in various styles. Like it all about handwriting handwriting generation in a good way. Like even though if we are giving an input of different handwriting, like it has strokes, letters, it is analyzing everything. And here is an example of like if we like different person have like different handwriting. If we are giving that as an input, and everything is consumed, like here example is like training example for the IAM online handwriting database, which is a wide range of writing styles. The variation in line angle and character size, and the writing and recording errors, such as scrubbing out letters in the first line and the repeated word the fifth time. Mixture density outputs and the idea of mixture density output network is to the use of neural network to parameterize a mixture distribution. A subset of the output are used to define the mixture weights, while the remaining outputs are used to parameterize the individual mixture components. Therefore, straightforward to defer, intimate, and pick unbiased sample form in contrast with restricted machines and other indirect machines. And here is the images of that mixture density output for handwriting prediction, and experimental results shown that networks ability to generate realistic handwriting sequences The network demonstrated coherency over long intervals and adapted to different writing styles, generated samples from real handwriting. Conclusion: the paper presents a significant advancement in sequence generating using LSTM and RNNs. Key contributions include modeling long-range dependencies and generating realistic handwriting. Future work could be explored further applications and improvement in sequence modeling. Thank you.